Hello students, now we will be doing the last topic of this first chapter, which is the superposition principle. It is not a new thing because the name itself, superposition, means what? When it is superimposed one after the another. This superposition principle is applicable when there are more than 2 point charges. Okay, so far till the Coulomb's law we have learned only about the 2 point charges, right? Now suppose, let me consider here in a system there are 3 point charges. Let's say, okay, say q1, q2 and q3. Okay, now let's say the separation between the charges, let's say for this is r13, the separation between the charges is let's say r12, and the separation between them is r23. That means these are the magnitudes of the charges. Now the question comes, what is the total force on any charge? What is the total force on, let's say, q1? Okay, that is the total force on q1. Means on q1 what should be the total force? Then on q1 the forces will be due to q2 and due to q3. Now if all of them, let's say if all of them are positively charged, I can take any, then on q1 due to q2, what would be the direction of the force along here, right? Force on 1 due to 2, right? Similarly, due to 3, what would be the direction of the force? This would be due to 3, the direction of the force will be along here, along this line, right? That means on any point charge, if in a system there are number of point charges, on any charge, if we want to find the force, then the total force on it is the vector sum due to the other charges, right or not? That means on q1 the force is what? Due to this and due to this, right? And what? Force is a vector quantity, so what it will be? It will be 1 2 plus q f13, right? Similarly, in a system, suppose there are so many charges, right? Let me name it q1, q2, q3, q4, let's say q5. My writing will be bad, huh? q6. Okay, then any point charge, suppose on q6, what would be the total charge? On q6 the total charge will be due to q1, due to q2, due to q3, due to q5 and due to q4, right or not? And due to q1 the force will be along here, due to q2 will be along here, due to q3 will be along here, due to q4 will be along here, and due to q5 will be along here, right? And these all the forces, what we need to do, we need to add them, what? In terms of vector. Why? Force is a vector quantity. So this is the principle of superposition. Are we clear with it? I will start up with a simple case. Let's take a simple example. Okay, I hope then it will be clear to us. Let us take 3 charges. Okay, say q1, q, let's say 2 charges, okay, q and minus q. Okay, and let's say this is given. Okay, give me a moment. Suppose they are at the distance of r. All right. Okay, now the question is where Q should be kept. Q should be kept. Should be kept so that force on Q is 0. See, this is a question. Okay, let me, and this is a question, and this is a, where Q should be. Suppose I have a third charge. Okay, I have a third charge. I don't know where. Suppose here, I don't know where it is. Where should I keep this Q? Okay, so that the total force on it is 0. Okay, now on Q, the forces on Q could be due to whom? Due to plus Q and due to minus Q, right or not? Right? Now due to plus Q, in what direction Q will be experiencing the force? Q will be experiencing the force along here, right or not? Right? And due to minus Q, Q should be experiencing the force along here, right? Here. Now, let me, due to, now total force, let me call total force, this should be what? Due to plus Q and due to minus Q, correct or not? The total force on Q is due to plus Q and due to minus Q, right? Now the total force, now this total force on this is how much? This is how much? This is 0, right? Now due to plus Q, what is the force? What is the force, student? This force is how much? Okay, K Q by, I don't know what that distance would be. Shall I call this distance? Shall I call? I don't know, right? That also I don't know. Suppose this is X. Okay. Then this will be how much? X squared, right? Now in what direction this is experiencing the force? Minus I cap direction. This is X, this is X dash, X is I cap, and this is minus I cap, right or not? In terms of vector we are writing. So this needs to be what, student? This has to be minus I cap, right? Then another, right? This is due to minus Q, right? Minus Q. Minus Q should be what? K, the magnitude only we need to write. Q by, what should be this distance? Total distance is what? R minus X squared. Now what is the direction? I cap, right? Now, right? Is it clear to you? Is it clear to you, students? Okay. So this total is 0. So if I transfer, if I take this one to the other side, then what it will be? K, Q, X square I cap is equal to K, Q, R minus X whole square I cap, right? K, Q, all can cancel, I cap cancel. So what is the remaining, student? This equal to X square equal to R minus X whole square. So what it is? R should be then X and X, so transfer it R. So X should be what? R by 2. That means what? For this plus Q to experience 0 force, it have to be kept right in the middle. Yes or no? Because whatever the repulsion, equal will be the attraction, right? So one will be pulling from this side, another will be attracting from this side. Yeah? So this is one of the example I did based on the superposition principle. You can see the text.